Good morning, Colonel Fischer, and welcome to Leeds Elementary School here in Elkton, Maryland. Our First Lady astronaut, Sally Ride, once said, "Our future lies with today's kids and tomorrow's space exploration." Cecil County Public Schools students are our greatest asset, and we are very excited for them, for their wonderful opportunity. We look forward to the future and what the children and space exploration will bring to our lives. Thank you, and have a safe trip.
Well, thank you for those great words. What questions do y'all have?
Okay, our first question is going to be from fourth grader Justin McMillan.
How did you become interested in working for NASA?
Well, Justin, it was when I was 6 years old, so even younger than you guys. I visited my grandpa down at Johnson Space Center in Houston, and this huge rocket, the Saturn V, was sitting outside, and I got to see it, and it just captured my imagination. And ever since then, I really wanted to do something with space and serve my country, so the Air Force Academy was a no-brainer for me, and the rest is history.
Thank you for that, Colonel Fischer. Our next question comes from fourth grader Chase Stallings.
What is the most interesting thing you have ever seen in space?
Oh my gosh, that is a tough question because so much stuff is cool. And it could be even the smallest thing, like how a bubble behaves when it comes off a connector, or it can be as the grandeur that you see when you look out the window. I think probably the coolest thing that I've seen so far is when I went outside for a spacewalk, just having no small little window to look through, but the entirety of space in my field of view. It was amazing and breathtaking, and I think just seeing the Earth in that way and the stars above them was the coolest thing I've seen by far.
Thank you, Colonel Fischer. Our next question is from pre-K student William Lehrer.
What do you like to eat in space?
Well, I like eating pretty much everything in here because I can play with my food, but my favorite is coffee balls. So I'll show you about a coffee ball. So coffee, I love coffee on Earth. It's pretty much my favorite thing. But in space, I get to make balls out of it. So check this out, and then suck the balls. Very cool. Here you go. That one got away from me. But as you can see, it's pretty fun to play with your food here in space. So I do. And that's pretty much makes everything my favorite dish.
Thank you. Our next question is from second grader Carly England.
What do you do? What do you have to do to prepare for a spacewalk?
Well, it's pretty tough. The suit is really it's you have to be kind of strong to work against the suit because it's pressurized when you go outside. So it takes a lot of training, physical training, and then we have this really big swimming pool in Houston called the Neutral Buoyancy Laboratory, and there's a big mock-up of the space station inside the pool, and then we go in the pool, and these awesome divers weigh us out, so it's kind of like we're in 0G and we can practice. So we do a lot of practice in the pool and a lot of studying on the systems that are in our spacesuit in order to go outside. But it's completely worth it because it's so fun out there.
Thank you. Our next question is from first grader Axel Patchell.
What is a typical day like for you on the International Space Station?
Well, actually, it's pretty busy. We get up, well, Peggy gets up earlier than I do, but we get up pretty early, work out. We have to do about 2.5 hours of working out a day in order to keep our bones and muscles from atrophying or losing part of our bones. And then we have just science and we fix things and we keep stuff clean and running and change out parts. So we're just very busy. The biggest part of our day is science. So we do almost 300 experiments over my 6-month mission we'll be involved in. And so we just keep very busy, and all of it's fun.
Thank you. Our next question is from third grader Ryan Dominic.
How is electricity for the space station generated, and what happens when the power goes out?
Well, we have really big solar arrays. So the size of the space station, if you go from corner to corner on the solar arrays, is about as big as a football field. It's huge, makes tons of power. And then those solar arrays charge batteries because every 90 minutes we go around the Earth. So there's about 45 minutes of light and 45 minutes of dark. So we charge up the batteries and then we use the batteries. If we have a problem, we have 8 different channels that we can use. So there's backups if we have a problem with our power. If we start losing too many channels, we have to start turning stuff off and lose science. So that's not a very good day. So we want to make sure we don't lose power, certainly not a lot of power.
Thank you. Our next question is from third grader Victoria Granger.
Can you have animals in space? If so, do you have any with you?
We do. So over the course of the space program, we've had a lot of animals in space. We've had fish, we've had mice, fruit flies, and we use animals, and they help us in our studies of different parts of not only the human body, but in general. And, things that you wouldn't even know, like a fruit fly has a similar cardiac system to humans, and mice have similar bones. So we're able to look at the effects of zero-G on those animals, and it's very helpful.
Thank you. Our next question is from kindergartner Abby Guns.
If something breaks on the space station will not function, how will you fix it?
And I kind of missed that one.
Okay, the question was, if equipment on the space station breaks or malfunctions, how do you fix it?
Sorry about that. My ears are getting kind of old. It depends on what it is. Some things we have spares for that we can plug in new ones. Sometimes it's outside, so we get to do a spacewalk to fix it. That's cool. Or it's something where we have to kind of take it apart and replace parts or fix wires. So it just depends on what it is. All of it's very fun because you're doing it in space, and they typically design all of the systems so that we can do them easily here in zero gravity.
Thank you. Our next question comes from 5th grader Solomon Pope.
What is the hardest thing to get used to in space?
Well, I don't know. I think I got used to it pretty quick because it's so fun to fly around and spin and play with my food. I guess the hardest thing to get used to, and I don't know that I ever will, is just being away from my family.
Thank you. Our next question is from kindergartner Lillian Rhodes.
What do you miss most about being on Earth?
Well, I know. It's my wife. I miss my Beagle Bandit and my girls. So I guess I miss most my family.
Thank you. Our next question is from second grader Jamie O'Connell.
What types of trainings are involved in preparing to go to the space station?
Well, it's a lot of training. We have to know a lot of things. There's an old saying called "Jack of all trades, master of none." That's kind of us. We have to be familiar with a lot of different things, from driving a robotic arm or doing spacewalks to doing different types of science skills. So we actually study systems on the Russian segment, the USOS segment, the Soyuz vehicle, as well as science and all the other skills. So it's 3 years about from the time you're assigned until you fly, and then you can't be assigned until you've had at least 2 years of training as an astronaut candidate. So a minimum of 5 years before you could fly. It's a lot of training.
Thank you. Our next question is from fourth grader Blake Holbrook.
While you are in space, what research are you doing?
Well, we're doing a lot. Like I mentioned, there's over 300 experiments during this 6-month increment. So we're doing bone research, protein crystals, stem cells, new robotics technology. There's just a huge list that we just can't remember because it's so packed with science. There's even an experiment or a set of experiments called nanoracks that is taking scientific experiments from high schools and other schools and flying them in a smaller kind of rapid development process so that we can get more science from spanning the spectrum all the way from high school all the way to advanced research. So we have quite a bit of science going on.
Thank you. Our next question is from first grader Madeline Whitley.
What is the coolest thing about being in space, and what is the most difficult?
Well, most difficult is that my wife's not here because I really dig her. The coolest, I can't decide. It's either the floating, flying and spinning all over the place, or the view. Both of them are pretty awesome.
Thank you. Our next question is from third grader Maddie Roberts.
How are you able to tell time in space?
Well, we have watches just like on Earth, but since we're going around it, somebody had to pick which time zone we would use, and they picked the Greenwich Mean Time, which is basically the time it is in London. You know how there's time zones Central, and you guys are in Eastern? Well, this one is the time zone in London. So that's the time we use all day long, and we get up at 6 o'clock on London time.
Thank you. Our next question is from kindergartner Nathan Polino.
How do you know when it is time to go to sleep when you can't tell if it is day or night?
Well, that's a good question because every 90 minutes it's a day and a night. What you ever go to a hotel room and they have those really thick curtains on the windows? Well, we have little sleeping quarters that basically is shut the door, and it's just the same as going to one of those hotel rooms with the thick curtains. We just close the curtains, and then we can't tell if it's day or night. So that works pretty good.
Thank you. Our next question is from first grader Jocelyn Zahn.
When you are not working, what do you like to do for fun on the space station?
Well, that's a good question. I like playing with my food, I like taking pictures, and I like flying around and trying to do spins and flips and all sorts of craziness.
Thank you. Our next question is from second grader Elijah Pfeiffer.
You go through so much training for this journey. Is there anything you felt you were not prepared for?
Wow, that's a really good question. We have a lot of training, and I think they did a good job. Some things you just can't train for because things don't float on Earth while we're doing our training. But I'm very lucky because I'm on board with two of the most experienced space travelers in history, Peggy Whitson and Fyodor Yurchkin, and they answer or guide me through the other stuff that I didn't quite get trained on Earth.
Thank you. Our next question is from fifth grader Alexandra Goodwin.
What tools are you using to study the effects of microgravity on bones?
Boy, we use a lot for bones. That's very important because we lose bone mass when we're on orbit. So we have help from our mice friends. We have used cell cultures and stem cell cultures. Of course, the biggest thing that we use is ourselves. We go through extensive testing both before and after our mission. And then, like I mentioned, all of our exercise is part of that process. So the biggest thing that we use is us and making sure, seeing how the effects were on our bones when we get home.
Thank you. We only have a couple minutes left, and we have a couple more questions. Our next question is from fifth grader TJ Taylor.
What emergencies do you have to prepare for on the space station?
Well, the biggest ones that we need to know, because we have to have those responses memorized, are if we have a fire, if we have a depressurization, like there's a hole in the station, or if we have an ammonia leak, because that stuff's really nasty.
Our next question is from fourth grader Karina Granger.
How will your fluidic study help the understanding of fluid behavior?
Well, it's kind of that study, the fluidic study, is looking at two things. One is slosh in a tank, in a fuel tank for space vehicles. The other is wave turbulence, which basically what we're trying to do is when you have a very complex model like weather forecasting, if there's one item like gravity that's really big, it's hard to model all the other little things. So we're modeling a thing called capillary action by removing gravity and studying it up here. And in doing so, we'll build a more complete model to better forecast weather on Earth.
Thank you, Jack. I'm going to turn it over to Allison Vesey, the Vice Principal of Leeds.
On behalf of the students and staff here at Leeds Elementary School, Superintendent of Schools, Dr. Diet Devine, and the leadership team, Council Executive Alan McCarthy and the County Council, Orbital ATK, and AIAA, we want to thank you, Colonel Fischer, for taking the time to talk with us today. Thank you for helping us to learn a little bit more about your experiences and research on the International Space Station. Over the past few months, you've become a well-known name here at Leeds Elementary School, and our students excitedly call you Two Fish. Walt Disney once said, "If you dream it, you can do it." My hope is that this brief interaction has inspired our students here to dream a little bigger about their futures, and we will someday see some of these fantastic students in space. Have a great day.
Well, have a great day. I'll give you a sideways spin before you go. I dare you all to dream, and I hope you have a great day.
Station, this is Houston ACR. That concludes the event.
Thank you all participants and guests from Leeds Elementary School. Station, we are now resuming operational audio communications.